All right, we are about to get started. Are we good? We're good? We are good. Okay, cool. Well, welcome everyone. Welcome the online audience as well. We are the AI user group. Who is attending for the first time? Nice. Cool, so welcome. We are organizing events around AI, and the idea is for us to train professionals on AI tools. So we do that through meetups, like tonight. We do also workshops, hackathons, and we have a big announcement today. We are about to move into our own venue. So it's been 2 years that we've been moving around, and we just signed a lease. So for the next 3 years, we'll be 2 blocks away, 972 Mission Street. And the goal is to organize weekly events, so meetups, workshops, hackathons, and for you guys to discover new technologies, to be trained on new technologies, but also to build through the hackathons, potentially meet up potential partners for new ventures. So we want to be this place where you can learn and build. So starting next month, we'll be there, and hopefully we'll have a packed schedule for you. Also, if you want to check this, we are organizing with our friends at ActiveLoop a conference. So it's on October 17, and it's a conference for data leaders. So if you are a data leader yourself, meaning you are managing AI, ML pipelines, or someone at your company is doing it, this is a conference really for this audience. There is not many opportunities for these data leaders to meet and to be trained. So this is the opportunity. It's free. It's usually $500 to get in, but it's free if you apply. So you can scan this QR code or send it to someone you think can be interested. Also, we are looking for speakers for our next events. We are organizing AI for developers, of course, but also AI for designers, AI for marketers. We have openings for AI for marketers, AI for designers as well. So if you know anyone who is either developing a tool for designers, marketers, developers, or using AI into their workflow and want to showcase something cool, don't hesitate. We are looking for speakers. Also, now we want to show you a video of one of our sponsors. It's N8N. So who knows about N8N? One person. OK, cool. So here's a video. It's a very cool tool. It's for workflow automation, and it's a low-code tool. So let's play that.
At N8N, the automation platform for technical teams. In this example, you're seeing I've got some nodes on my canvas. Each node executes and passes its data along to the next node. But what I'd really like to show you is our new advanced AI functionality. In this example, I've created an AI assistant that helps me interact with my Google Calendar and lets other folks book an appointment with me. So how this works in a nutshell is this agent has various dependencies that it needs. It has the LLM itself. It has some memory, so it can handle multiple conversations at once or multiple threads in the conversation. And then it has various tools to understand how to fetch availability in my calendar and to book that appointment. So let's do a quick example demo of this, and then we'll see how it works. So let's see when Max is available next Tuesday. So what my AI agent is doing now is it's understanding them asking for availability, and so it's using the tool to fetch my availability. The agent knows when today is, so it knows when next Tuesday is, and here now it's listed the various slots that are available. Let's book something for 4:30 p.m. Okay. And so my agent is still running at this moment. Great. So the agent, before it makes this request, it understands that it needs my full name and email to complete the request. And so let me specify that. So now that the agent knows that it has all the information that it needs to make the call, it can book the appointment on my behalf. Great, we can see we've got a confirmation here. And if I check in my calendar, we see at 4:30 p.m., we booked that appointment. Now, let's see what's happening under the hood. So my chat trigger here is collecting the responses from myself and sending it along to the agent. This is an arbitrary step, right? So this could be a webhook trigger. This could be your own custom trigger that you've coded. That really can be anything that you'd like. It pipes the message into the agent, which then interacts with its various tools. In the agent itself, I have a system message. I'm letting it know that what its task is, and I'm also giving it what today's date is, and that appointments are also 30 minutes. I myself am not a prompting expert and wrote this rather quickly, so you don't have to be an expert to start getting value from this. And then the magic really happens in these HTTP request tools. So each one of these tools allows my agent to consume an API endpoint and understand how it works. So we've got the Get Calendar Availability tool, and we've got the Book Appointment tool. So setting one of these up can literally take a minute or two. As you can see, I've described very simply when it should use this tool, call this tool to book an appointment in the calendar. I then define the endpoint that it should consume. I define the credential to use if necessary. Since we have Google Calendar credentials in n8n, I'm using a predefined credential type, but I could also use a generic one if it's something like a proprietary system that you're connecting with. And then from there, I'm essentially defining the payload to send in my body. And as you can see here, I've got some static parameters. These are the things that I don't want my LLM to manipulate. And then I have placeholders for the things that I do want it to manipulate. And as you can see, I can blend static text with these dynamic parameters that I'd like the LLM to control, or my agent to control rather. And then if I want to, for added control, I can, for these placeholders that I've defined, I can add some more definition on how the AI should interact with those parameters. So there can be a description, and I could even define the expected data type of that. So again, I'm constraining what my agent does, so we have more predictable outcomes when we ship this to production. So from here, I could add more tools, of course, depending on what I need my agent to do. There's various off-the-shelf tools to understand the world or perform math, etc. I can interact with an arbitrary API endpoint. I could write a tool in code, and I can even call other n8n workflows. So this workflow that you saw over here could be consumed by my agent. We have hundreds of native integrations, so it's a really fast way to get your agent interacting with the tools and services where you have valuable information that your users, customers, etc. might want to interact with. I'm Max from n8n. We've just scratched the surface in this demo, but make sure to check us out.
All right. And it's open source, so if you want to install it on your own environment, it's also possible. All right, so this is the agenda for today. We're going to start with Joshua right here. He'll introduce us to the power of small language models. Then Philip will talk about 3 misconceptions about RAG. And then we'll add only for the on-site audience, not for you, online audience. So that's why you need to attend events in person, because then you have some benefits like this. Ivan from Google will introduce us to the era of Gemini. And then we have community news. So it's basically a free forum for you. You have 1 minute. So if you have any announcement you want to share with the community, if you're hiring, if you are looking for anything, ventures, fundings, please, you'll have like a minute to present that. So start preparing for your pitch. And then at 8:05, we'll start networking and pizza. And then doors close at 8:50. So let's start with Josh with at Prem AI.
Thank you, Cyril. And what's up, AI user group? So, there's nothing but events happening in San Francisco these next few weeks, so it's been kind of crazy. I've been going from event to event, but I'm glad I can make it here tonight. So I'm sure we'll find some more things to do tomorrow and the next day and the next day after that. It just doesn't stop. I'm from New York, so we're not having this much craze with AI as much as we are here in the Bay Area. So it's been really awesome to see the excitement around it. So before I get started, I just want to know, who here in the room has used a small language model at all? Yeah, that's cool. Anything in production yet, or just to test out? Has anyone used anything in production at all? No? Cool. Well, at Prem AI, we focus a lot on small language models, making them performant so you can build, fine-tune, deploy, and optimize them into production. And we can integrate them into any application, and then super language agnostic and so forth. So there's lots of things that I could say about Prem AI. However, this talk tonight really isn't about our product. I really want to highlight our experience with small language models, bring you from the beginning about small language models, and kind of what we experienced building our own small language model and where we're going in the future with it as well. So at Prem AI, I lead product and DevRel. So I've had the opportunity to come to a lot of events like this and meet developers from across many different organizations, and here to tell my story about the power of small language models and what the future is. So nowadays, language models are driving this technological revolution that we have going on, and they're leading to some significant improvements in natural language processing. So large language models always are great, and they pose some new challenges though, due to the computational resources and energy that they use. And that's where small language models come into play, or SLMs. Now, given that they can be really effective in certain areas that we'll talk about, small language models really are just models with smaller parameter sizes. Now, what a small language model is today and what a small language model is going to be next year and the year after that is totally going to change. I have talked to some companies where they consider a model that is 13 billion parameters to be small, and others are saying that no, it'd rather be 500 million parameters and so forth, right? So, as we continue to see the evolution and introduction of Llama 4 or Llama 5, GPT-5 and so forth, the parameter sizes are going to change drastically. So I would just say, if you're thinking about small language models in the next steps, things are going to change dramatically overall. So let's hop in and talk, and I'll tell you what I'm going to talk about today, the problems that small language models solve, where do they fit in, and what my team has learned from creating our own SLM. And we've created a few of them already, and we're going to continue to build some more. Now, the evolution of language models sparks the question, can smaller models with significantly less parameter and memory emulate such emergent abilities in larger language models? There's a lot of really cool things going on with knowledge distillation and so forth that's happening, but we've seen this evolution of models going up and up in parameter size and then kind of going down. Well, this is a little bit outdated. This is from 2022, so things are a little bit changing a little bit here. However, it still kind of poses the same till today. So language models have been shown to exhibit a range of emergent abilities from summarization, arithmetic, translation, and common sense reasoning. As they scaled up in size and are trained on diverse and large amount of data, you've seen that these abilities that are suggested from language models are not only learning learning the surface of patterns of language, but also acquiring a degree of semantic and logical understanding of the world around us in the text. So although research breakthroughs in CNNs and attention mechanisms have contributed to significant advancements in the recent narrative of AI, it can be encapsulated into one concept though, and that concept is scale. So when we're increasing data, model size, computational resources, this has led to the enhancement of performance and the use of energy. The notion that bigger is better is frequently accepted. We live in America, so everything's big. I work for an Italian company, so when they're here this week, they actually think everything that we eat is huge. This is frequently accepted without any question. So, however, it's essential for us to consider the consequences of developing applications that are using the largest available models. So small language models rely on more pre-existing knowledge and semantic priors. And this is gained through pre-training and even with examples that contradict this knowledge. So in contrast, large language models can overcome their pre-existing knowledge when provided with examples to go against it. So despite potentially having stronger pre-existing knowledge compared to the smaller models, we'll see kind of the difference here. And so in other words, smaller models kind of stick to what they're taught during the pre-training process, and even show some conflicting examples between large language models. So what problems do small language models solve? So they excel in simple tasks, such as they're great in scenarios where internet connectivity is limited or unavailable. They can be deployed directly on device, on edge, on premise, on servers, and enabling local inference. So this is all without relying on cloud-based services, which is super powerful for the next step of where small language models are going. So when I mention edge, for those who don't know, that can mean on tablets, on phones, in automobiles, right? So think about all these other places where there is a processor that isn't a GPU or an LPU or a TPU, or whatever chip all these companies are coming out with. You carry one inside of your pocket every single day. And this is where small language models can definitely excel, because we are able to run models that have this pre-trained knowledge, and even combined with knowledge distillation, we can create a very powerful companion on your own device. Look at what they're doing with Apple Intelligence and what's happening at Google Pixel as well. This is an evolution that we're watching right in front of our faces. So also in applications where near instant response is crucial, such as real-time conversational AI or like sensitive decision-making systems. So like any type of emergency application that's being made, small language models can excel there because of the reduced latency that it takes to get a response from the language model itself. Also for organizations that are on budget constraints, small language models use less computational resources, which means that you can save your organization money from doing so. So they offer a cost-effective solution, and their smaller size translates to different computational requirements by reducing the need for expensive hardware. So this kind of leads back to edge devices as well, right? GPUs are not cheap, and it's much different from how they used to be. So during the development and testing phase, where resources are limited, again, small language models can be a developer's best friend. Right? They can easily be integrated into resource-constrained development environments, such as local machines or low-powered servers, and allows developers to quickly iterate and test their applications and fine-tune models without a costly infrastructure. So this is great, like a really cool example nowadays. You're seeing that there's this model that's a larger model that may act as a teacher, and the smaller models that act as a student. This concept is prevalent within this point here. Now, for specific tasks to achieve better fine-tuning out the box versus LLMs, while large language models offer an impressive out-of-the-box performance, based on general knowledge, they may not always be the best fit for your domain-specific task. Whereas when you're fine-tuning small language models on domain-specific tasks, you can yield a superior results compared to the generic knowledge that a large language model has. So by focusing on narrowing the task and leveraging relevant training data, a fine-tuned small language model can capture the nuances in terminology and patterns that are targeting a specific domain and leading to improved accuracy and relevance. And that's pretty much what we also work at Prem. So in summary, small language models are really powerful, versatile for a wide range of applications, and they enable offline inference, handle latency constraints, can save you money, and so forth. Pretty much what I explained before. And again, just in plain simple words, SLMs are fast, they're cheap, they're predictable, they're customizable, and they're great for privacy, because that's what edge devices allow you to have. Now, just because I'm here talking about small language models doesn't mean I think that they're the best, right? Like, we're doing a lot of research. At PremAI, we're also an applied research lab. We work together with some of the top universities in Switzerland and across Europe as well to then help evolutionize how small language models are being used in production, and also on top of that, fully homomorphic encryption to then increase the privacy behind these models as well, since there's clearly like this privacy problem within the AI space right now. So while small language models offer numerous advantages, there's certain challenges that we face, and that could be for limited contextual understanding. So it is like, to a point where if you use a pre-trained small language model off the rip, it has an inferior contextual awareness compared to a large language model that's pre-trained. So due to fewer parameters, of course. And small language models may struggle to understand and generate responses that require deep contextual awareness and understanding. But this is where fine-tuning, RAG, and other techniques also come into play, and like knowledge distillation as well. So with shorter context windows, you may have a limited ability to maintain the context of a long conversation with a small language model. But then that also leads into the evolution of agentic AI and having a hierarchical orchestration between a large language model and a swarm of smaller language models that could work together in order to complete domain-specific tasks agentically. So they can reduce, when you're using a small language model, you may come across reduced accuracy and performance. So smaller models often provide less accurate and lower quality outputs compared to large language models, and particularly in nuanced, complex tasks. So just pretty much like a generalization of that. You may come across less creative responses from a small language model, so due to limited training data and fewer parameters. And I'll say it again, this is again where something like knowledge distillation comes into play that can improve this, but it does take a lot of work to do. And small language models may produce less creative generic responses and also repetitive outputs, so something to look out for. There's this data dependency, so trading data quality is super important, and the performance of SLMs heavily relies on high quality data, right? So the inaccuracies and biases of training data can significantly impact their performance, and their limited knowledge base of SLMs may also lack the extensive knowledge found in a larger model. And then there's some scalability issues and task-specific limitations. While SLMs can be fine-tuned on specific tasks, they are generally applicable across a wide range of tasks as well, and they have some adaptability issues where they can struggle in rapidly evolving or requiring updates to remain relevant. But that's where tool calling comes into play as well. So there are some really great emerging use cases for large language models. I'm sure I don't have to explain what RAG, retrieval augmented generation, is here, but there are some really cool advancements that are happening with RAG and small language models. We released Prem1B, which I'll talk a little bit about from our experience, that heavily focuses on just RAG implementations. You're seeing a lot of cool things happening with small language models that are also multimodal. And data labeling and using few-shot prompting is starting to advance there. SQL generation, which I'll talk a little bit too, because we released a model called Prem Text to SQL as well, where SQL generation is really changing the game. And then, of course, agents and function calling. So something to really look at. So just on the topic of function calling, open source small language models like Mistral 7B, Functionary 2.5, or Llama 3 8B are revolutionizing function calling on the open source level. Not that the closed source models are not doing so, but these open source models that are coming out that are much smaller are great for proof of concept and even rolling into production as well, and it can also help save your organization money. So think about having a small language model that's open source and running on an edge device. You can cut your costs significantly. Now, these models offer performance, efficiency, and accessibility, allowing developers to customize and deploy on a single GPU or a single processor, whatever one you're using. The open source nature of these models democratizes the access to these advanced functionalities and the function calling capabilities that come with them. And it fosters collaborations within the developer community. So I actually met with like a company this week called ToolHouse, which is doing that as well, who we're looking to collaborate with, who has like actually changed the whole function calling game where within 3 lines of code and using their SaaS, you can literally just have function calling added to any language model like that without having to have a huge amount of JSON that's just in the middle of your code trying to interact with some type of function or API. They've really honestly just made things a lot easier for developers. So developers can quickly prototype and deploy applications without expensive infrastructure and with the needs so forth with tool calling. So traditionally, RAG has been associated with large language models, if we're looking back to GPT 3.5 and GPT 4, which have demonstrated some impressive performance in this domain. But these models with vast knowledge and embedded parameters have the ability to generate fluent and coherent responses while incorporating information from external sources as well. So, but however, such large language models for RAG applications come with certain drawbacks. There's always hallucinations that happen. So these models with billions or trillions of parameters require an immense amount of computational resources and storage capacity, right? So the vast knowledge that these models come with that are embedded with them, while impressive, may not always fit your domain-specific task and can stay relevant even with RAG. So this is where small language models and RAG are best friends in a sense, because small language models offer a more efficient and targeted approach to handling RAG applications by focusing on specific domain-specific domain tasks, and SLMs are designed for acquiring the knowledge from RAG while maintaining the compact size and staying relevant. So just imagine a scenario where you build a RAG system for a specific domain like healthcare, who we work a lot with, or finance, or entertainment. So instead of relying on general purpose knowledge, your model won't be so broad when you have a small language model, and you can create an SLM that's specifically for that domain. So that also kind of is relevant to our work at Prem AI with Marvel Studios, who has proprietary IPs and wants to make specific models for all their superheroes and stories that they're telling, and animated series and so forth. So if you want to learn more about that too, you can come and find me and I can talk more about our use case with Marvel. So if we embrace this, this notion of using retrieval augmented generation, graph RAG, and whatever comes after that, with small language models, you can unlock some new frontiers when it comes to this whole evolution that's happening within AI. So at Prem, again, we're an applied research lab and a startup. We have a SaaS as well that you can use. But we also focus on making open source contributions, and we're going to be open sourcing our platform soon. But before that, we also released Prem 1B Chat and Prem 1B Instruct. And these are transformer-based decoder-only SLMs, and they're trained on next token prediction. So the architecture for this model is based on Llama 2 and Tiny Llama with flash attention. So just note that Tiny Llama was trained with the context window of the context length of 2048, but Prem B has the context length of 8192. So just considering this release with the new models that are come out from Llama and the performance benchmarks, we went with the Llama architecture based on transformers. So we explored a lot of other things like Mamba architecture, MOE architectures, H2O, stable LM, Phi, Llama models, but we ended up on Llama 2. So just talk about some of these results here. Tiny Llama appears to be a top performer in this case, and it shows some strong performance across different tasks. And I could talk about all these other ones as well, but I mean, essentially our model isn't perfect, and that's open source. However, we're continuing to make more and more improvements. We're not a company that provides small language models like at the heart, but we do this in tandem with our research and what we're doing with our platform as well. So we're continuing to improve these and add more models to our whole offering. So even with that being said, we have Prem 1B SQL, which we just released the other day, who like my team and I have worked on. So Anindyadeep, who is one of our ML engineers and DevRel at Prem, worked really hard on Prem 1B SQL and the fine-tuning process of that as well. And you should definitely check it out. It's benchmarking pretty well against some of these other models for text-to-SQL, and we're going to continue to actually build it up and get to a 7 billion parameter model for text-to-SQL, which is another emerging piece of the industry to capture here. So on our platform, you can fine-tune, deploy models super easily, small and large, open source and closed source. That being said, I mean, that's pretty much it for my talk today. If you'd like to learn more about what we're doing at Prem AI and like how small language models can affect your organization, please come find me. And if you have any questions, I'll be here for a little bit. Thank you.
All right, cool. Thanks, Josh.
Thank
Do
you.
we have questions for Josh? Yes?
So Josh, do you folks at Prem AI have your own like small language models, or are you helping with like using other models and making them, like using the small versions and then productionizing them? So
Yeah, good question. So yeah, like in tandem, like we're a research lab, and then we also have our own startup and SaaS and so forth. So on the research side, we are making our own small language models. We have about maybe 5 or 6 different ones out on Hugging Face right now with Prem text-to-SQL, the chat and instruct versions, and a few other ones that we have available. So we do work on our own, and we're going to continue to push out some more, and that we're fine-tuning for different use cases. Like we have our own clusters in Finland. We work with the University of Switzerland and Italy as well. So we have access to work with them in their research lab, where we're at the forefront right now, actually a fully homomorphic encryption that we'll put on top of the small language model. So we're working with governments and different entities that have proprietary data or sensitive IPs and so forth. We can do that. But on the other end, on our SaaS, on our platform, we also have the ability to, we host models. We host models all the way from open source, GPT, Anthropic, Google Gemini, Gemma, all the really popular closed source and open source models from Llama, Mistral, and even the uncensored ones. You can use those on the platform, integrate with a few lines of code, and you don't have to have any type of vendor lock-in. Our whole purpose of what we do at Prem AI is to unlock AI sovereignty, so that when we're working with certain companies like Marvel, or we're working with the Swiss government or other companies over there, they can ensure that when they work with us and they want to use models across the board from open and closed source, that they can own their models, own their data, and trust and have a trusted place that they can host it on. So we do on-premise deployment. We have virtual private clouds. So we come up with a bunch of different solutions for companies. So pretty much we have our own, and we have everybody else's. Yeah, thank you.
Great. And regarding your current clients, what are the most successful use cases you saw for the use of small language models?
Yeah. So we have a couple right now that are really heavily on small language models and even agents as well. So we have, and I can bring it up here actually. BitGPT.network is in our family of products as well. BitGPT is a decentralized AI wallet that you can chat with, and it uses prems, SLMs, and fine tuning as well, so that it's a wallet that you can actually chat with and like send funds, check on the market. Pretty much you see from this example here, and pretty much it helps make blockchain, crypto, and trading more accessible to folks rather than having to manage like 3 different hot wallets, a cold wallet. One of the biggest problems within blockchain is just adoption. So this is kind of where we have this intersection of AI and blockchain. And at the core, we started as a Web3 family, right? Like the founders of Prem are from SingularityNet and a few other Web3 startups. We came here. We have our use case with Marvel Studios, with them. And then we also have another small language model that's being used for a payment platform called Celix. And Celix is a payment processor and marketplace, and they're using Prems, SLMs to actually capture fraud detection as well. So there's a lot of people, this payment platform allows you to pay with fiat currencies and cryptocurrencies, but there's a lot of sketchy people out there that may be doing some type of fraudulent activity. So they use the small language models to capture that beforehand, make sure that people are having a smooth process. So they're coming out with some really cool stuff. They have a really easy to use API and SDK, and we're looking to collaborate with more companies and push out some more things. So check out our documentation if you want to learn more about Prem, and if you work in an organization that is in Gen AI, of course, talk to me, and we do a lot of things in open source.
Nice. Thanks, Josh. One more question? Okay,
Sure.
That one.
Hey, Josh, great presentation.
Thank you.
One quick question about the differences you might have observed across model sizes and their behavior. Have you noticed that smaller models have less tendency to hallucinate, or are they equally good at remembering factual information and stuff like that? So what kind of behavior differences do you see across these?
Yeah, great question. So kind of back to some of my slides before, they're not perfect, but the things that, there's definitely some hallucinations that happen. I would say if you just use a pre-trained model without any type of fine tuning or RAG or anything else like that, you'll definitely see it. And even with RAG, there's still hallucinations. But the things that do make it better are knowledge distillation, and then we're doing a lot of testing in this hierarchical orchestration of having a larger language model sit at the top, kind of like something similar to federated learning without the decentralization piece of it, where the larger model can sit at the top, there's a central data point, and the SLMs can then capture the data from there. So it does improve the accuracy in that sense. However, right, they're not, I don't think they're perfect. And even as we're going into this next step with agents as well, I don't know, someone needs to point me in the direction where agents are being used really well in production. And because a lot of it's prompting and other things that are going on. So it's pretty tough. But I would say with fine tuning, RAG, knowledge distillation, we've seen improvements on our end. And this is something that we want to, fully bake into our platform further and further and improve. So that's why we're doing a lot of research on it.
Nice. Let's give Josh a round of applause.
Thank you.
Thank you, Josh.
Yeah.
He will be available during networking.
I just want to say one thing too. We're hiring. So we're looking for DevRel, and we're also looking for a head of marketing. So if you are that person or know somebody, come and speak to me. Thank you. Appreciate it.
Cool. And next in line, Philip from Elastic.
This is what it should do. It will be fine.
Perfect. So, hi, I'm Philip. I'll try to keep this a bit more interactive. Just shout your answers if there are any, and I'll repeat them so everybody in the recording can also interact or hear what we're saying. But let's dive into 3 misconceptions about RAG. Before I dive into RAG, just to be sure, like, who knows what RAG is and how RAG works? Who would like a refresher? Okay, I see still a few hands going up on RAG. It's always good to dive into the fundamentals of what we're talking about. Like, retrieval augmented generation has, well, 3 parts or 2 main parts. So how I would always describe this is we have your question that is coming in. That is the top left corner where you see custom question. And then you could use an LLM just to answer that. But the problem about that is that maybe the LLM is too old and doesn't know what you're asking about. So if you ask for very current information, the LLM probably doesn't know about it yet. Or you might ask about some data that is private or that is too specific that the LLM doesn't know it. And the idea about RAG is that you provide additional context to the LLM that it can give you better answers. So the classic example would be you're working in a big corporation and you want to know what your insurance plan is. And a generic LLM has obviously no idea what your company's insurance plan is. So you would need to provide the context what your company's insurance plan is. So what you do is, when you basically, the customer question, we go down to the business data. This is where you could provide your specific context. That would be your insurance plan, for example. So based on the question that you ask, you retrieve the relevant data. Then you forward that data to where the plus sign is, where you have the question and the custom context that you provide. That is going to the LLM, and you instruct the LLM to answer the question with the context that you provide. So you would add your insurance plan that it can then give you the right answer. Potentially, you could even pull data live from the internet if you need to query something really up to date to this minute that is not in your business data, but that is an optional step. But the general idea is that you retrieve additional context that your LLM can give you better answers. That is the general idea about RAG, and then there are 100 little details about it, but this is the bigger picture. So why am I talking about that? I work for Elastic, the company behind Elasticsearch. We're the most widely used search engine that you can run yourself. I've been talking about search for almost a decade at this point, I want to say. So if you've never seen Elasticsearch, if you search in Wikipedia, behind the search box, our software is doing the search, and in many, many other places, if you try to find something, we're often involved. That's why we are very keen on that entire RAG topic, and also some of the misconceptions. So let's see how this is going. For those of you who have used more RAG before, who agrees that you have to use vector search for RAG? 1, 2, 3. Okay, this is one of the points where we would disagree, because RAG, the retrieval part, is really just retrieval in any sense, whatever is relevant. It doesn't have to be vector search. It's just getting to the relevant answer. And it's actually funny that maybe Google is biased for me, but I just took this screenshot before when I typed in vector search is, and the first result is not enough. That is the one where we would agree. Anybody wants to shout why vector search might not be enough? Or where is vector search great and where is it not great? So maybe let's start with traditional, or sorry, yeah, please shout.
It's not great for really complicated filtering. Like, you need to filter a lot of things out.
Yeah, so it's not great for filtering. That is one aspect. I think that is actually a good point. And very specialized. So maybe let me take a step back around the classic way to search something was keyword search. So it's very much like you match a string or a substring and you try to find that concept. And that works very well as long as you use the right words. And that is very much what we have been trained for many years, that we have a search box and we think like, what are the keywords that I need to type in that are existing somewhere that I want to hit, and then I want to get something back. And that works, and maybe you define synonyms that even if you use a different word for something, it will still find something that is relevant for you. So that works, but where it doesn't work so well is if you have this more vocabulary mismatch, you didn't define the right synonyms, you described more of a concept, that is where vector search is coming in. Also, vector search gives you options to search not just text, but also unstructured data like audio or video or images. And you extract the meaning that is not in a textual representation right now, but you can search more for the semantic representation of something. However, that semantic representation falls short, for example, if you search for a very specific name, that representation that is normally a dense vector, think about it as an array of floating point values. It's not very good at if you search for a very specific string. Vector search is not necessarily great at that. So, for example, if you know a name and you want to search for a specific name, that is where keyword search is doing a much better job. And your users get really angry when they know that the string exists somewhere in your documents, but they don't or are not able to retrieve it. So in many cases, you want to have this combination of vector search and keyword search. And maybe you want to have these, like you mentioned before, these additional filters. So for example, if we have a restaurant search, we might include a geo filter where we say, only give me the restaurants within 5 miles or 10 miles, because if they're on the East Coast, it's not really relevant to what we are trying to do here, if you're searching for a restaurant. Or give me only the 4-star restaurants. All of these, you want to have more complex retrieval to actually find what is relevant, because the point about RAG is really, retrieval is very broad, it's also very old, but it's really just about finding the right context. How you get there is almost an implementation detail, and vector search is an important piece or an important option you have, but it's not the only way how to get to that additional context, just to make the generation better then. LLMs are only useful for generating the answer, because in the graphic that I've shown you before, we were generating the answer at the end with the LLM. Who sees the LLM in that place? Okay, nobody dares to raise their hand anymore. Where else could LLMs be relevant, if not for generating the output? Yeah? Processing the input, yeah. This is one of the examples I have here. So let's assume we have this problem here. We have a dessert, but we forgot what the dessert is called. And maybe we can describe it to an LLM. And we can say like, oh, it has ladyfingers, and it's from Italy, and it has cocoa powder. And then the LLM will actually say, ah, you're looking for a tiramisu. And you might not even want the LLM to generate you the output, because maybe you just want to retrieve the recipe for the tiramisu. You don't really need an LLM to rephrase the recipe, because you really just want the recipe to make the tiramisu. But you might have a problem to actually finding what you're looking for, or maybe to make it a bit broader, you might use an LLM to rephrase your question, just to either fit your data better, or just to make it more generic, or just have a better question so that you can retrieve better context to give a better answer afterwards. The other place where LLMs can come in really handy is data is normally very messy. There is this joke in data science that you spend 80% of your time cleaning up data. And that is actually a place where LLMs can give you a hand, that they can help you to clean up your data and structure it better and make it more approachable, maybe give you synonyms automatically, maybe remove certain errors, maybe do something like named entity extraction, like this text is about this person, or this is the overall context, or give you more summaries, and you also search the summaries. All of these can very easily be done by LLMs, but it's not just at the end when you output something, but the LLM comes in to both ingest the data and collect it, maybe rephrase your query just to make it better, And then maybe the LLM is also used for generating the output. Right now, we seem very focused on this, like we have a very large document and we just want to have a summary or we want to have the output rephrased, and this is a good goal, but that is not necessarily the thing that we will always want. Because, for example, if you have a search in a store, you normally just look for the thing that you're looking for. You don't really need an LLM to reformulate the result. You just want to find something sometimes. In other cases, when you have like a 50-page PDF and you want to get the gist of the PDF, or you want to have like an explanation of like a certain section, LLMs totally make sense for the output as well. But it's not always that the generation makes sense at the output or is needed there. Another point that we see quite often is that large context windows make RAG obsolete. Who believes that? Okay, nobody dares to raise their hand anymore. If nobody raises their hand, why?
What's the definition of large?
Well, larger than, let's say, larger than what we could have in the input tokens like 6 or 12 months ago.
That's the thing where the context window keeps changing, and your RAG will automatically be able to handle more, right?
Yes, but I think some models like have an input like at least 10, if not more, pages of context, which might be enough. So this will be an ongoing question. Or initially, the input context windows were so small that everybody was always like, of course, we have more data than this context window can have. As the context windows keep expanding, maybe there are use cases where you don't need it, but in most cases, you will have just way more private data or data that you want to add as context than what is reasonable to give to your LLM. The other downside is more input tokens normally take more time and cost more, so you want to limit them. The other thing is that sometimes, and that depends on which benchmarks you believe, the LLM gets more confused if you provide too much context or things that are not relevant, and then it will actually give you worse answers rather than if you just provided relevant context, it has a more focused answer, rather than giving you a very broad answer because it got confused by all the input. This is a pretty active area of research, but NVIDIA has recently published an interesting paper in defense of RAG in the era of long context language models, which is interesting because you would think NVIDIA sells GPUs, so they would always want more input tokens so they can process more. But they came to the conclusion that, and you can see it in the orange and the blue charts, that in their benchmarks, and they've done quite a few benchmarks in this paper, was that the long context window gave you often worse answers than if you had RAG, though they did use various tweaks around RAG. Or this is one area that is under very heavy research, I would say, right now. So this paper, for example, has these two concepts of like, first, provide enough context. So they retrieve a lot more pieces of content rather than just one, because what oftentimes happens is people just look for the top one document or maybe top one chunk and just provide that as context, and that might not be enough. The other thing that intuitively we're often doing is like, we have a large document and it's for vector search, to keep that reasonable and the relevance high, you might chunk it to break it into these different chunks. And you might intuitively sort by chunk relevance. What they're doing is they're keeping the chunks within one document in order as they appear in the document. So you can see the blue on the left-hand side is like the darkest blue goes to the lighter blue. So the relevance, let's say, is 0.9 for the first two chunks, then 0.8, and then 0.7. But it kind of like mixes up the order, and that can confuse the context as well. So what they're suggesting is that at least for one document, you keep the order-preserving RAG, that you keep the order of the chunks, even if then here the least relevant of, let's say you retrieve 4, is the first one, but it might still give you better context to keep them in order. Other tricks around chunking might be that you figure out like the worst thing, oftentimes not in context, you can do is if you mix content together that does not belong together. So that figuring out the separators in a document is very important. For example, if you have a header, that is normally a good point to break, because after, like, the part before a header is normally very different and doesn't belong to it. So this is definitely something where you should have a break, and you shouldn't just say like, oh, I always take like 100 tokens and mix them together across whatever boundary there might be. That is one thing. Another pattern that I think Cohere described last week was that they always added a summary of the entire document to each chunk, and they said that's helping the relevance of the chunk, because it doesn't only find the parts that are in the chunk, but in kind of like in the context where it's coming from, and that gives you much more relevant chunks. Another approach that is interesting is called hide, which the general idea is, if you have a chunk, it's, let's say, a paragraph of text, so it's some amount of text. When you have your search query, it's often much less text. And the idea is vector search. The relevance around vector search is very much built around the similarity between what you're searching for and what you're finding. So what this hide approach is doing, it's taking your query, it's generating a representative document of that, and then looks for similar documents, because it says like, you basically have like, let's say, paragraphs of text, and you're looking for similar paragraphs. So what you need to do is you need to generate a relevant or representative paragraph, and then you look for similar paragraphs rather than just like 10 tokens or so to search for. So there are a lot of different tricks and ways how to tweak context or to make search more relevant. But the main point here is that search and retrieval is a big field. There are many ways you can do it, but even larger context windows don't make it obsolete to find the relevant pieces, because only with the right information the LLM can actually generate context in the right way for you. I think we have some more time, and we can actually let's do some stuff live. I always feel bad if I just talk. So let me make this maybe my keyboard shortcuts changed. I always need to use this. Maybe coming back to my first point about like vector search is potentially not enough. Since we're a search company, I always like to talk a bit about search. And my main example is always Star Wars based. There is this scene in the Star Wars movie when they're sitting in this vehicle and he's making that gesture and then he's saying a phrase. Does anybody know what the phrase is? At the very beginning of the movie. It's a famous phrase, "These are not the droids you're looking for." That's always my go-to way of explaining how search works. And I'll start with keyword search because it's the older one. So what we do here is we'll build this analysis pipeline. And this is kind of the equivalent of what you would have in a model to give you the embedding representation of your text. What we do here is we'll throw out HTML, for example, because nobody's going to search for HTML tags. We'll break it up into words. We'll lowercase everything because nobody cares for upper and lowercase when you actually search on Google, for example. Remove so-called stop words, so little words that appear in almost all text and add very little meaning. And then we stem. Stemming basically reduces a word to the word root, so you don't care about singular, plural, or anything.
Share the right screen.
Sorry. Yes. I'm not showing you the right screen. I don't want to extend, I want to mirror. Let's see, now we're looking better, sorry. This is what you want to see. You throw out the HTML, you break out the tokens, you lowercase, you remove the stop words, you stem. I create this, I put everything into an index I call Star Wars. and now I show you what full text search would do. And this is kind of like what happens behind the scenes. I'm taking this like, these are not the droids you're looking for. And when I run this, what you actually get out is droid you look. This is what full text search could do behind the scenes, the way I have set it up here. So for example, if you would afterwards search for droid, it basically generates a list of all the tokens that you've ever extracted, points back to the document, and then you could easily find this document that talks about droids. And it has a start and an end offset, so it knows where the hit is if you want to do highlighting. It knows the position in the document if you would look for a phrase. I know droid u is a very weird phrase, but because one is basically position n and the other one is n+1, you know that these were next to each other. And this is what you can do in full text search. So you can just store these, and then you can search for, so I have, these are not the droids you're looking for, and then I also store like who said it, and no, I am your father as a phrase as well. And then I search for droid. Will I find the droids here with my full text search? Yes or no? Yes? Why? Yeah, so we've lowercased it, so the upper and lowercase shouldn't make a difference anymore. We have stemmed it, and the stemming stems down to the word root of droid. So searching for droid, and the search term runs through the same pipeline, will find my droids. The problem is, though, this vocabulary mismatch. If I say, I don't know, Android or machine, I wouldn't find anything. Or for example, no, I am your father. So if I search for father, you will find something. But if I say, for example, dad, it wouldn't find anything because it's really just about this lexical search. So this is the limitation that you have with lexical search. Vector search, on the other hand, and I'm running this against AWS Bedrock with Titan, and I ran these before because I wanted to take out my tokens before sharing my screen. So we could do completion, and it doesn't know anything about it. This is kind of like the end-to-end example at the end, that if you then inject like who said these are not the droids you're looking for, it could answer the query. But to keep it short, I'm setting up a semantic Star Wars index where I keep what I've done before, and I've just like add that Titan embedding. I take the documents from my previous index and throw them in here. And let's just retrieve that. Just to show you what a dense embedding looks like, is like we have, these are not the droids you're looking for, and that vector representation of this with this Titan model looks like this. So you have an array of floating values. This is the representation in a dense vector. And then, for example, if I start searching for robot now, and this is still the query. Here we are still searching for the old keyword-based field. But if I search for my Titan dense vector representation, then it will actually find these are not the droids you're looking for. It will also find the other document. That is the other funny artifact of vector representation, is that everything has some distance to everything else. Because the dense vector representation, and we have a cosine similarity, even if it's totally unrelated, you will still have some distance even to the most unrelated document. There is no correlation at all. But it gives you what is closest, and robot is closest to that. These are not the droids you're looking for, because the model understands that droid and robot are in the same space, or like closely related. It will give you this as the best matching document here. And we have avoided this vocabulary mismatch. But for example, if we would have OB1, for example, a keyword-based search would do a much better job of finding OB1, because we have that exact match, than a dense vector representation. And you can also, for example, then search for dad, and this will do a good job, or a good enough job, to find I am your father as the closest match in my documents here. And you could, for example, also combine those where you combine keyword-based search and vector search just to get the most relevant documents. So all of that combined these are the options that you have with search. And they give you much better results than just vector search alone. But the retrieval part is really about like finding the most relevant context. And only with that context can you then give the right answers. To wrap this up, we also have an event. If this was too short, we have a free full day event on October 1st, so next Tuesday, here in San Francisco as well. If you're interested in that, you're all welcome. And with that, I'll just leave that up for a moment. Questions?
Yes, let's start some questions. Do we have questions for Philip? Yes?
You gave an interesting example of those two different methods of search going into retrieval. I imagine you've played around with a whole bunch of other kind of permutations on that. For example, have you ever experimented with using LLMs or semantic models to come up with alternative keywords and then using that in a keyword search or other combinations like that?
Yeah, you totally quote. So LLMs are, by the way, a great tool to make search better. So either you could do automatic keyword generation. It might be a bit domain specific. Sometimes your users are the best source for those. So if you have existing queries, what your users are searching for, those could be a good feeder into that. And then you could say or tell an LLM, give me 5 permutations for each one of those, and then you widen the net. So you can totally do that. We also have a proprietary model that is a sparse vector representation that kind of does that automatically for you. It basically gives you a keyword expansion, but with the weight, how well it is matching. So we have done that as a model as well. So dense vector representation gives you a lot, but it's not the only approach. There's also sparse vector representation, or SPLATE is the generic technology if you're looking for that. You can do that. Another area where, for example, LLMs are great is to generate test data, to actually verify what you're doing with your queries. So it's really not, keyword search can totally be complemented by LLMs. And also coming back to one of my other points, it's not just the RAG generating the output, but LLMs potentially have many use cases in the wider search spectrum. And ideally, they solve the boring problems for us, so we can actually spend more time on fun stuff or solve the actual problems.
Cool. We have time for one more question.
So you just now said that LLMs are pretty useful for search. Can you elaborate on that? How? What's that echoing?
So useful is a pretty broad term. It can be reformulating your query. For example, coming back to your other example of the synonym expansion, you could have the LLM reformulate the query and say oh, give me 3 different variations of this query and then run all of them and see what comes back. Or maybe you can tell the LLM approximately what data you have and you want to restructure the query. So it could be you formulate better queries to retrieve more relevant data. It could be in generating the output, which is the classic RAG. It could also be in generating test data to actually validate what you're doing. So there are various ways to use LLMs just to work around search. You can do a lot of manual work, so you could define all your synonyms manually, but that's probably tedious, and people have done that in the past and spent a lot of time, but maybe you can automate a lot of that and just be faster to solve the job. So LLMs totally have their space in search and software development as a whole, but I'm just focusing on search right now.
Are you using LLMs right now for search and Elasticsearch?
Oh yeah. I mean, so the one area where I think LLMs are the easiest starting point for RAG is to avoid the malicious users and have the benevolent users who want to cooperate with them. So for example, our support team and our sales team are using that very heavily because we have large internal knowledge bases of how to solve technical issues, how to write or how to answer a sales email. And so that's the classic RAG example. We ingest all of that data and then use an LLM to generate an output. And then we have a user to actually validates that, tunes it if necessary, and then uses it. Where RAG is, I think, sometimes a bit trickier is like when you do the prompt injections or talk the LLM into doing something it shouldn't do. There's this well-known example of, I think, a Canadian airline where people talk the LLM into saying you can cancel your flight for free. And they went to court and the airline lost and had to cancel the flight for free because it was their system saying that. So if you have malicious users or users that try to attack your system, LLMs can be tricky, and like putting all the guardrails in place can be tricky. But if you have users who want to use the system and just try to make the best out of it, it's just like us coding or generating SQL queries or finding more relevant content. It's a great use case. If you have a hostile environment, it's interesting, or people are learned to be a bit more cautious. I think there was this other case with like, you get a free car, or you could talk the LLM to get a free car. So there are all kinds of things that went wrong over time, and we are learning how to not fall into those.
All right. Thanks, Philip. Let's
Thank
give
you.
Philip a round of applause.
And if you want to have stickers, I have a ton of stickers on the table there. You can
Yes,
click them
plenty of stickers. It's also time to say bye to our online audience. Bye-bye. See you October 15 for AI for Marketers. So we can cut the live stream. And we'll